Hello students, I am just recording this lecture so that you are able to see it whenever you are free. Today's lecture will be a recorded lecture. Okay. Now today's topic is on normal Zeeman effect. Normal Zeeman effect for single valence electron. Single valence electron system. Normal Zeeman effect for single valence electron system. Now this is a small derivation that is there to see what is the effect of Zeeman effect in case of single valence electron system. A small derivation is there. Now what happens is, due to the application of magnetic field, due to strong magnetic field, due to strong magnetic field, LS coupling is broken. LS coupling LS coupling is broken in the presence of magnetic field, and L vector, the orbital angular momentum vector, it splits. Orbital angular momentum vector, it splits in the presence. त्याच्यामध्ये बदल होतो. Orbital angular moment वर परिणाम होतो. L splitting takes place. L vector जो है तो split होतो, and because of that we see the effect of the magnetic field in the form of the normal Zeeman effect. Now when we say that LS coupling is broken and splitting is due to the L vector only, we'll consider spin. We will be neglecting spin. So if we neglect spin, then the angular momentum that is there is given by PL is equal to LH by twice pi. Angular momentum is quantized. Okay? L is the orbital angular momentum quantum number, H by twice pi. That is the quantum condition. Now the orbital magnetic moment is given by mu L. It is equal to E LH by 4 pi m. Mu L is given by E LH by 4 pi m. That is equal to, you can put this as, now you know LH by twice pi. LH by twice pi, LH by twice pi is PL. So E by twice m आणि बाकीचं जे राहिलेलं आहे त्याच्या जागेवर आपण काय लिहिणार आहे, PL. Okay, so mu L is equal to E by twice m PL. Or you can go further, we can have the ratio between the two. Mu L by PL is equal to E by twice m. E by twice m. Now in the presence of magnetic field L vector, the L vector precesses around, it moves around the direction of magnetic field. L vector, it starts precessing around the magnetic field. Magnetic field च्या भोवती तो फिरायला सुरुवात होतो आणि मग त्याची प्रिसिशनची फ्रिक्वेन्सी जी आहे, फ्रिक्वेन्सी ऑफ प्रिसिशन, it is given by frequency of precision is given by omega L is equal to, frequency of precision is given by omega L is equal to H mu L by PL. Okay? That is equal to, the mu L by PL is E by twice M. So H E by twice M. H E by twice M. You can write. Next. Now due to this precision, precision L vector around H, the electron that is there, it gains additional energy. Additional energy. So the additional energy is gained by electron. Additional energy is gained by the electron, and this additional energy, that is delta E, is equal to, it depends upon this frequency of precision multiplied by the projection of vector L. L is a vector, right? That's a projection on the field direction. Projection of L on field direction. So delta is, that is the change in energy, that is the additional gain in energy, is equal to omega L, that is the frequency of precision because of the magnetic field. And projection of, multiplied by projection of L on H. So we will wrap some part of this so that we can continue the derivation part. Okay. Now this delta E is equal to omega L. We put that as into projection. This projection of L on H is given by PL cos theta. PL cos theta. That is the orbital angular momentum, and the angle between the orbital angular momentum vector, cos of angle between the orbital angular momentum vector and direction of H. Now WL, we have written it as H E by twice M. Now PL, we had already written PL as equal to L H by twice pi. Okay? PL, that is orbital angular momentum, is L H by twice pi, and this cos theta is that. Now just what we'll do, we'll just rearrange the terms and see how we get it. Now we put E first, capital H, small h, divided by twice, this 4, I'll write pi first, 4 pi m. EHH by 4 pi m, L cos theta. L cos theta. Now this L cos theta is nothing but ml. It is the orbital magnetic quantum number ml. So L cos theta is ml. So if you put that, so you'll get EHH divided by 4 pi m ml. Now what is ml? As I have told you, ml is the orbital magnetic quantum number, and ml, it takes values. ml kutta values jeto, it starts from minus L plus 1 up to 0 to plus L. Suppose if L is equal to 2, L की values are 2 असेल तर ml काय values घेईल? ml will be minus 2, minus 1, 0, 1 and 2. So it takes values from minus L to plus L including 0. So ml, much values it takes? Twice L plus 1 values. ml किती values देतो? Twice L plus 1 values. It takes twice L plus 1 values. So this is delta E, that is the change in energy that takes place इन द इलेक्ट्रॉन्स मोशन, इलेक्ट्रॉनच्या ऑर्बिटच्या मोशन मध्ये एवढा बदल त्या ठिकाणी आपल्याला बघायला मिळतो. आणि त्यामुळे आपल्याला मॅग्नेटिक फील्ड मुळे व्हॉट इज देयर, दी L level it splits into twice L plus 1 levels, that is ML levels. ML च्या जेवढ्या व्हॅल्यूज असतील तेवढ्या व्हॅल्यूज मध्ये ती स्प्लिट होताना आपल्याला दिसते. सो दिस इज वन पार्ट ऑफ द डेरिवेशन ऑफ फाइंडिंग डेल्टा E. Now delta E is equal to this. Now what we'll see is its effects on the spectra. Spectra वर त्याचा काय परिणाम होतो, एनर्जी लेवल वर त्याचा काय परिणाम होतो. आपण डेल्टा E थोड्या वेळासाठी लिहून ठेवू एका बाजूला. डेल्टा E is equal to EH divided by 4 pi m into ml. We'll wrap this part over here and see the next part of the derivation. Derivation चा आपण दुसरा भाग बघू. Now if we put E1H and E2H as the two energy levels, E1H and E2H are the two energy levels in presence of magnetic field. H आपण त्यासाठी वापरला magnetic field. आणि E1 and E2 in the absence of magnetic field. Magnetic field च्या absence मध्ये असणारे energy levels. These are the energy levels in the presence of magnetic field. These are energy levels in the absence of magnetic field. And the ML values, respective ML values in presence of magnetic field are ML1 and ML2. Okay? Magnetic field च्या इथेच ते ML व्हॅल्यूज असतात. याच्यासाठी ML1, याच्यासाठी ML2 जर आपण घेतलं तर the energies that are given will be E1H will be equal to magnetic field च्या presence मध्ये तर E1 plus हा जो फॅक्टर आहे तो चेंज जो आहे तो EHH डिवाइडेड बाय 4 pi m आणि ml च्या जागेवर इथे काही ml1 तसंच E2H will be equal to E2 plus EHH divided by 4 pi m ml2. Now the radiation, frequency of radiation emitted या दोघांमधला एनर्जी डिफरन्स आपल्याला. फ्रिक्वेन्सी ऑफ रेडिएशन इमिटेड दिस h nu will be equal to E1H minus E2H. h nu will be equal to E1H minus E2H. That is equal to या दोघांमधला डिफरन्स E1 minus E2. ओके आणि प्लस आता ही EHH हे दोन्ही कॉमनच आहेत त्याच्यामध्ये. EHH डिवाइडेड बाय 4 pi m that is the common term आणि इथे ब्रॅकेट मध्ये ML1 minus ML2. Right? So the frequency of emitted radiation will be h nu is equal to या दोघांमधला डिफरन्स EH1 या दोघांमधला सबट्रॅक्शन आपण इथे घेतलं E1 minus E2 आणि ML1 minus ML2 with this factor being common over here. Okay? Now this is equal to, that is h nu will be equal to हा काय असेल, ओरिजिनल फ्रिक्वेन्सी असेल h nu 0 प्लस आता याला आपण ML1 minus ML2 याला आपण म्हणू डेल्टा ML. याला काय म्हणू, डेल्टा ML, चेंज इन मॅग्नेट क्वांटम नंबर EHH by 4 pi m delta M. Okay, or you can put this as nu is equal to nu 0 plus delta ML एच ने डिवाइड करायचं फक्त आपल्याला ई कॅपिटल एच हा एच कट होऊन जाईल 4 पाय एम. नाउ दिस इज द equation for frequency in the presence of magnetic field. Okay, nu zero is in the absence of magnetic field and त्याच्यामध्ये बोलणारा हा बदल आहे, change in the frequency of some part of it so that we can continue. Now the selection rule for ml, that is delta ml, is it should be either equal to 0, +1 or -1. ml should be equal to 0, +1 or -1. So if you put delta ml as equal to 0, so nu आपण याला 1 म्हणू is equal to nu 0. Put 0, nu 1 will be equal to nu 0, ml upon delta ml 0 for ml equal to 0. Nu 2, the nu 0 plus EH by 4 pi m. Okay? When we take ml as equal to +1, ml चला गया +1 घेतला था. Nu 3 upon third frequency. Nu 0 minus EH by 4 pi m, and we take ml as equal to -1. ml जर -1 घेतलं तर अशा पद्धतीने आपल्याला ही एक फ्रिक्वेन्सी, ही एक फ्रिक्वेन्सी आणि ही एक फ्रिक्वेन्सी इथे मिळते. आपण याला काय म्हणू, टेल दिस एज डेल्टा न्यू, याला आपण डेल्टा न्यू म्हणू. चेंज इन फ्रिक्वेन्सी दॅट मच अमाउंट त्याच्यामध्ये फरक. So we'll get nu 1 as equal to nu 0, nu 2 as equal to nu 0 plus delta nu 3 as equal to nu 0 minus delta nu. जैसे 3 lines depending upon the selection rule, that is delta ml is equal to 0, 1 and -1. We get these 3 lines in the presence of magnetic field. Magnetic field च्या presence मध्ये ही फक्त absence मध्ये एक line असते. In the presence, these two lines are added to this. हे दोन lines तिथे add होताना आपल्याला बघायला मिळते. So this is all about the spectra that we see or effect of magnetic field in case of single valence electron system. Now, actually जेव्हा आपण diagrammatically जर बघितलं आपण, if you see it diagrammatically, for example we take with L is equal to 2 असेल तर त्याची समजा ही लेवल असेल. L is equal to 2 is this is the energy level of that single energy level. L is equal to 2 आणि खाली आपण L is equal to 1. These are the energy levels. याच्यामध्ये ज्यावेळेस ट्रान्झिशन होईल इथे we'll see a frequency of radiation nu 0 being emitted. Now what happens in this is in the absence of magnetic field, when H is equal to 0, so the magnetic field 0 असेल. पण magnetic field जर apply केलं some H equal to some value H, then what happens, this L level it splits up. त्याचं काय होतं, splitting होतं. का किती मध्ये स्प्लिट होतं, तर ml values L is equal to 2, when L is equal to 2 ml will be equal to -2 -1 0 आणि 1 आणि 2. So it will split into 5 levels. That's a splitting किती levels मध्ये होईल, 5 levels. It splits into 5 levels with ml values being equal to 2, 0, 1, 0, -1 and -2. And L is equal to 1. It splits into 3 levels with ml values being equal to 1, 0, -1. इथं 1 आहे तर 1 0 -1, इथं 2 आहे तर 2 1 0 -1 -1 -L2 प्लस L. आणि इथे काय होतं, एकच लाईन होती. आता इथे सिलेक्शन रूल आपल्याला माहिती आहे. व्हॉट इज सिलेक्शन रूल, डेल्टा ml इकडे लिहून घेतो. सिलेक्शन रूल इज डेल्टा ml इज इक्वल टू either 0 plus 1 or minus 1. So we'll see what is the result over here. Now if you put delta ml is equal to minus 1 जर घेतलं आपण तर 0 to 1. 0 minus 1 is minus 1. ही एक लाइन. Minus 1 to 0. Minus 1 minus 0 is minus 1. Now minus 2 to minus 1. Minus 2 minus minus 1. So minus 2 plus 1. So it is minus 1. So these are the lines with delta ml equal to minus 1. Delta ml with is equal to minus 1. Following the selection rules. Okay. Each of them have the same frequency. प्रत्येकाची frequency ही सारखी असते. Next we'll see delta ml is equal to 0. Delta ml is equal to 0 means it is 1 to 1, 0 to 0 and minus 1 to minus 1. So this is delta ml equal to 0. Next we'll see delta ml is equal to plus 1. Plus 1 will give you from 2 to 1. 2 minus 1 is 1. 1 minus 0 is 1. And 0 minus minus 1 is again 1. So that is delta ml equal to plus 1. Okay. So these are 3 lines over here. These are 3 lines. These are 3 lines. But these 3 lines have the same frequency. These 3 lines have the same frequency. These 3 lines have the same frequency. If you look at the spectrum over here, या ठिकाणी जर absence of magnetic field मध्ये आपल्याला एकच लाइन दिसते with frequency nu 0. But here in the presence of magnetic field, what we see, delta ml is equal to 0 च्या तिथे इथे nu 0 ला एक लाइन दिसेल. Delta ml is equal to minus 1 च्या तिथे एक लाइन with nu is equal to nu 0 minus delta nu. आणि इकडे एक लाइन या ठिकाणी with frequency nu 0 plus delta mu. So these are 3 lines that we see in the presence of magnetic field. Magnetic field मध्ये 3 line and in the absence of magnetic field there is 1 line in the spectra. There is 1 line in the spectra that we observe. So this is all about the Zeeman effect, normal Zeeman effect in case of single valence electron system, a short derivation and the figure that is there. So we'll stop here for today. Thank you everyone.